My name is Philipp Salvisberg. I'm from Switzerland, Winterthur near Zurich, and I work for a company called Trivadis. Trivadis has also a subsidiary in Bucharest, and I hope some Trivadians are also joining this session. So, hello, colleagues. And I'm also the maintainer of the SQL Developer extension. So that's why I'm talking about this topic. I used unit testing in the Java field first, and Jacek convinced me to try out utPLSQL, and it is really cool, and I'm a fan, and it has some advantages compared to testing from Java frameworks. So I recommend to have a look at it, and this presentation will be half presentation and half demos, and I will show you how you can use it in SQL Developer, and I show you some things Sam already showed you, but I'll show you additionally also something called code coverage, and this will come at the end of this presentation. So, okay, let's start with an introduction, and it continues there where we were with the question at the end of Sam's presentation. Nowadays, everything is about test automation, and from my point of view, this is also a driving force why utPLSQL is more and more used. Because I think most of us are working in agile projects and have to deliver workable outputs within 2 weeks. 2 week sprints, Kanban, or whatever you are using, something like that. And therefore, testing is also very important because at the end of such a sprint, we want to know whether our piece of software is working or not. And of course, we can compare it. We can find that out manually, and we did that in the past with tests we run ourselves, but not in an automated way. So in the end, testing is everything, as Sam showed. We are defining some output, some expectations, and we run some code, and we look if our expectations are met. And if these expectations are met, then we are all good. And if we can do that in an automatic way, then we are much faster. So my expectation nowadays when I develop software, whether it is with Java or whether it is with PLSQL, I want when I check something in my bug fix branch, in my feature branch, and then in my development branch, that it will be automatically tested as soon as I've tested it, checked it in. So that's my expectation. And then I get automatic the feedback, is it okay or not? Of course, I can also run it in my development environment, but if I forget to run everything, I get the feedback afterwards. So that's the part of the integration testing, and it is very valuable. And that's the point where I see that you're becoming faster when you have such kind of tests. I have software suites where I really have to make sure, where I have thousands of tests which have to run first to make sure, okay, this is still working. So I'm quite confident when I have this kind of test automation. So that's a bit the background why I think it's becoming more important just to be more efficient, because you are using something like utPLSQL. So what is the scope of utPLSQL when you test, when you use it for testing? Basically, everything you deploy into the database. This means, what are you deploying? Types, packages, procedures, functions. These are PLSQL code. So yes, you can expect that you test that with utPLSQL. But also views. You can check if views provide the right output. These are basically select statements. Also in the with clause, they may contain some PLSQL, but you can check them as well. do they provide the data you expect? So in the end, for me, it's always when I program, don't do it the test-driven way. I start typically writing code. At a certain point, I try to start checking it whether it delivers the right result. And nowadays, when I do that, I start writing a piece of test code to check that. And this is helping me. So that's the difference to when I've done that earlier, as Sam showed in his example, where you just run a select, a query to check your stuff. You can do that also with testing tools. That's the difference. So you can check views, you can check triggers, of course, and you can also check constraints. So obviously, it doesn't really make sense to check if a not null constraint is working. This is basic functionality, and it's not worth to write a test for that stuff. But maybe you have a check constraint which is a bit complicated with a complicated regular expression, and you want to make sure that it really works and checks the stuff what you want to do. And instead of just trying it out on the command line or in SQL Developer or your IDE, whatever you are using, you can write the test for them. So that's the scope of PL/SQL, basically everything you deploy. So when we look at the utPLSQL, then this is more a suite. It's not just a single tool. The core component is deployed in the Oracle database, and it's important to note that it doesn't need a repository. Of course, it has some tables there, but these tables are only caches and temporary data. So when you install a utPLSQL version, it's no problem to upgrade it. Basically, you deinstall it and install a new version, and that's it. All the information is metadata-based, special comments in the test packages. We call them annotations. It's like in the old world with Java 1.3, where we used special comments for annotations because utPLSQL does not provide real annotations. So they are faked annotations. So this is the part we deploy in the Oracle database. But utPLSQL has more. It comes also with plugins. Basically, the utPLSQL project provides two plugins. The SQL Developer plugin extension I show you today. And since the beginning of this year, we have also a plugin for PL/SQL Developer. That's the all-round automation tool available on Windows only, which is really a quite good IDE. So I have a lot of customers working with that one. Both tools are really good. What I like is that the commercial tool vendors have started to provide plugins as well. So Toad comes with a utPLSQL out-of-the-box plugin, and DataGrip, the tool Sam used, it's from JetBrains, the company that also has the famous product IntelliJ. They provide also a plugin for their IDE. So you see a quite good base there. And there is more for test automation. There is a command line client, which you can integrate basically in every environment you like. And there is also a Maven plugin. And both options provide you produce various outputs. These outputs can be configured. You can produce multiple outputs. And one of the famous outputs is a JUnit report, where it's a XML-based output, which can be plugged in basically every environment. There are similar outputs for the product from JetBrains or the product from Microsoft. But there is more. There is also code coverage for ZonaCube, coveralls, and so on. Additional reporters where you see when you run a test suite, you see how many of your code has been touched by the test execution. This is also available. And in the end, you can integrate utPLSQL in every CI environment which is available. So there's really no limit because every CI environment is capable to run a command line client and to process the output produced by a JUnit reporter. So this is really quite cool. So that's the base. So this is a bit of a repetition. I won't spend too much time here. So when we write the test, how does it look like technically? As I said, we use annotations. These are special form of comments. Comments starting with minus, minus, and the %, and then some keyword, which is the annotation. So we add metadata to the test, to a package specification. And in this case, we flag this package name, test package name, to be a test suite. So that's the meaning. We have to place it within the package specification. We cannot place it outside because this will be lost when we deploy it into the database. This way it's available. So behind the scenes, utPLSQL will scan all the package specifications for annotations and store them in their repository, and so it finds that out. There are two mechanisms to make that very fast, so you don't really feel it when you run your tests, usually. Okay, and the next thing we have to flag is the test procedure itself. We flag here the procedure name to be a test. That's it. So this is the most simple version of a test definition I can come up. And of course, there are more. There are more annotations possible. You can flag test packages as performance tests, as slow running tests, or whatever. So you may just run a part of it if you like. And of course, there are a lot of additional annotations available for flags, stuff which you run at the beginning for your test step setup, or stuff that you run at the end for your tear down process. I don't have really time to explain that everything, but it's very well documented on the utPLSQL website. So when we look at the test implementation, it's not that much. It's similar things Sam has shown you. I show you here one of my favorite features in utPLSQL, and that's the comparison of cursors. I have here a sysref cursor for an actual value and for an expected value. And what I do here at the end is I just compare actual and expected value. I may also define this join clause here. It's not really necessary, but it's possible. And then I get a very detailed report. So this works with all data types that are supported in the Oracle database. And that's some addition. We talked about Oracle 21, and Oracle 21 came with a new data type JSON, and this JSON data type is not yet fully supported in utPLSQL. But if you don't use it already, then it's not a problem. It will be supported in one of the coming releases. It shouldn't be a big deal to do that. But right now, this JSON binary data type is not supported. Besides that, every data type is supported. You can use arrays, object types, whatever you have in the database, you can compare it. And this is really an advantage compared to other testing suites outside of the database. And then for some of these matches, you have additional functionality, like here, this join by or unordered, excluded, and so on. So that's the test implementation, the definition. When I run it, I can run it via SQL Plus, via SQL CL, similar as Sam showed previously. I get the output via server output. That's one way. I can also query the result. That's one way. I show you afterwards the way how we run tests in SQL Developer. So these two lines enable output and just run my test package or my suite, whatever I want. I have here options to define a suite path just to run a part of it, to include some text tags, to exclude some slow running tests, something like that. That's possible. And in the end, when I show that on the screen, I get this output from audits that I see I actually got 3 rows, but I expected 4 rows. And then I get the information about the differences, that 1 row is missing, the department 30 row is missing in this result. That's quite nice. So that's stuff which works on the command line. And this is one reporter which shows stuff on the console via the DBMS output, and other reporters show that in JUnit output format. Okay. When it comes to the installation, how do I install utPLSQL? You go to the website, download the release, go to the source directory, start SQL Plus as a sys user, and call the script install headless.sql. That's it. A user utPLSQL is created with this password in these user table spaces. If you want to change these parameters, for example, you need the changes because you don't have a user table space, then you can pass these parameters to the script. And it is installed within a minute, something like that. To install the SQL Developer extension, there are several options. One option is you go to this GitHub release page there and download the most current version. That's 1.3 currently. And then you start SQL Developer, go there on the check for updates menu. And then this window pops up here. At the bottom, you see install from local file, and you select the zip file you downloaded previously. Press next, 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 restart SQL Developer, and you're ready to use utPLSQL in SQL Developer. So now we start with a larger demo section. As I mentioned at the beginning, if you have questions, do not hesitate to interrupt me. Open your mic and ask your question. That would be nice. It's always good to have some interaction, and I'm ready to answer this question. So don't be shy. Good. When we run that's the last slide before the demo. When we start testing stuff, we have basically 2 options, and most of us have already code deployed in the database. So we could start from scratch, just write the test, or we could use our existing packages and say, hey, analyze these packages and generate some skeletons for me. I will show both approaches. I will start with the approach from scratch. So I switch here to my screen on SQL Developer. Yes, it is visible. Good. What I will show you here is an example which populates a depth cell table. I think everyone knows the employees and depth table from the Oracle, and I will populate a combination of these 2 tables. Per department, I see also the department name and the sum of the salary of each department. Salary, department 40 has no employees, therefore the salary is null. And we will test a procedure that populates that table. This procedure looks like this. It's called load from top. The first step it does a clear depth cell. It deletes the content of this table I showed you before. It deletes also an arrow table, and it prints some DBMS output text. And then it does, in this case, it does an insert into this table based on this select statement. And then it does a commit. That's important to note. It's not really a good practice to do that, but nonetheless, it's doing it here. And then at the end, it also prints some output. So we want to test that. And we start from scratch. Okay, I close that. So what I do here as first thing, I open a worksheet, and the utPLSQL extension comes with some code templates. So I have a code template for a package specification, so I don't have to type everything. I want to create a test for the ETL package. That's the one here. And the procedure I'm going to test is this load from tab procedure. That's the ETL package. That's it. And maybe you ask yourself, why the heck is this called T2? Because in this scheme I already have some test packages. I'm sorry, I have to refresh that. So I've already some test packages here, and I don't want to override them, so I called them T2. As you heard before, Sam called them UT, whatever you like, just to have no conflict. So that's my test here. I have a test suite definition, also a suite path, and the test annotation. I can deploy that. This is working, so let's call utPLSQL test from the code editor here, and I can execute it. It's not really a big surprise that I get here an error message. What you see also here is a nice hierarchy. That's a feature of the latest version of the plugin, and you see the impact of these things. So PL scope is the top level, then I have all tests, then I'm here in the package ETL T2 ETL, and then this is the procedure. And here it says, hey, this does not work because I don't have an implementation for that test. Makes sense, I could implement that test. But before I do that, I want to show you something else. You can disable unimplemented tests. And utPLSQL comes also with snippets, and we have snippets for annotations. And one of these annotation I want to use here is disabled. So I can drag and drop this information here and say I want to disable that test. So I can run that again, go back to my tab here for utPLSQL, rerun the stuff here, and you see I have one disabled test. All are marked here as disabled because I've disabled them. So I don't get an error anymore, but it's not really useful. So I'm going as a next step to implement the body. For the body, I have also a template. I choose that here. That's the ETL package, load from tab, load from tab, and ETL. So that's the implementation here. And as I've done it before, I can install that. This should work. I should be able to rerun it here. And in this case, I don't get an error anymore because the body is here. What I get is a failure. And the failure is normal test business. It says the actual number here, the actual value here, does not match the expected one, the one. So therefore, I get an error. It really makes perfectly sense. So what I could do here, I could check and count the number of rows. I know I expect 4 rows here. I say, okay, I want to count rows here. It's my tests. And to get the actual value, what I do here as a first step, I delete from the depth cell table. That's the target table. Basically, I don't know what happens behind the scene. Therefore, I do that step. It's not really necessary, but nonetheless, sometimes you want to be independent of that implementation. And the next step is I'm testing the load from tab, load from top procedure. Should be here. So this table should be now available. And the last step here is to select count star into actual from depth cell. Right, the expected value I've upcoded here with 4 as I know them, and then I do the comparison with the actual expected. This should work. So let's deploy that and rerun the code here. And it's green. But what I have here is a warning. And as Sam explained you before, utPLSQL comes with the capability that it sets automatically save points at various positions and does a rollback to that save point. And now it finds out that my code at some point has done a commit. And he said, hey, when you are going to use commit, then I cannot do the rollback. So I issue here a warning. So I have two options, either to get rid of the commit. Three options, I say, okay, I don't care about warnings, but basically I would like to get rid of this warning. So I copy here the recommendation and add here the rollback manual stuff and deploy it again. Deployed everything. So when I rerun it now, then utPLSQL knows, okay, there is no, I have to ignore that commit behavior and rollback behavior and don't issue any warning anymore. So far, so good. But this test is really simplistic. So what I want to do is a bit more. I want to add a second test, a test that really does a comparison of rows. So I'm going to copy that one. And I'm going to change it here. This will be the one. This will be the one. And then I have to implement test procedure. So that's the load from top 2, load from top 2. Okay, this looks good. And what I want to do here now is to compare rows. And for that, I don't need integer values. I need a sysref cursor. Ref cursor. And below also. And then the population of the actual is quite similar. So I copy that down. It's delete, that's the population. The difference is here in the select. I want to populate my ref cursor. So I open actual for select not count. It's basically all columns, that's right. And let me add here an order by clause. Depth no, it's here with an underscore, that should work. And for the expected value, it's quite similar. I want the ref cursor for the expected value, and I use here a prepared view source view, which I can conveniently query here to get an impression what's there. So these are the 4 rows. If I do a test here, I could also create a union all query where I prepare all these 4 rows as a result. That's also possible, but it's a bit easier here. So I guess I'm done with that test. I can deploy that. It's working. So I'm rerunning my tests here. And now I have 2 tests here. One, load from top 1 and load from top 2. But what the hell is top 1 and what is top 2? Maybe I should not just comment my code here. Or instead of commenting my code here, I should add a description to the test. And I do that here, load from tab. And here I do a count rows. And here I do also a load from tab test. And the compare rows. So deploy that again. Rerun my tests. And I see, okay, this is now understandable. This is a bit slower because it does a comparison. That's nice. So far so good. So that's the happy case, and for such a simple one, that's easy. What I want to show you is what happens when you get some differences. And I create here a failure, for example, when I change the sort order of the actual values. So we have a different sort order for the actual and expected. And therefore, I expect also some failures. So let's look at that. And what I got the failure, in this case, I expected it, so I'm happy. And I open it up here a bit, and I see detailed information. I see the ref cursor has a count of 4 rows for the actual and for the expected also for 4 rows. And I see here it doesn't make sense to create test for counting rows only when I also create a test which compares all rows. So you see that based on that result. And of course, I get the differences. And here, all the differences for every single row is reported. For the first row, I get this difference. For the second row, it's not 30 and 20 and so on. That makes sense. It's quite nice. So if you have to write these differences report for yourself, it's time costly. So basically, you are saving time when you're using utPLSQL. So let's try something. How could I fix that? I could fix that if I add here the same order by clause, but that's not fun. There is also another option. I can say when I compare these rows, these actuals, I can say there are some hints for the expectations. This one option here I can add is say, when you do this comparison here, it doesn't matter how it is sorted. Sort it yourself, the whole set. So I run that again, and I run my test here. And in this case, everything is good, even if here and here different sort orders are used. So let's go a step further and produce difference row-wise. So remove here a row from the actual value. I can do that with a where clause, where depth no is not equal 40. So I remove the depth of 40 from the actual value. So what will utPLSQL report me here? It reports here that the actual rows are 3 and the expected rows are 4, and I got one missing row. And this is something I like very much. So it's very precise. It said, I expected 4, I got 3, and this row is missing. And this is why it's important where you put here actual and expected. And if you are working with JUnit, it's just the other way around. So you have to relearn it always when you switch the tools. So that's important. So it's really a nice result you get here. I can try that out here as well for the expected result when I remove here the 40 by the where clause and install that and we run that again. Then I get the message 4 actual, 3 expected, and I got an extra row. I got here the actual provided the row 40 and I didn't expect that. So I get very precise error messages, and that's what I like very much when using utPLSQL. So I'm going to remove this unneeded stuff here to complete that test. So this should work. I do a final run here, which should be green. That's the green bar we like when you're doing the tests, and we all set here. So that was testing when I start from scratch. But I mentioned at the beginning that there is also a possibility that I could generate some tests. How does that work? I have here an ETL package, and I'd like to generate some packages for that. For that, I just show you something in the preferences of utPLSQL. In the preferences, you find code templates. Maybe if you worked with it, utPLSQL installs you additional code templates. We've seen that one. That's the one I used when I created the package body. I had to enter here the package name and the procedure name and the package name at the bottom, at the end. Everywhere where I had these placeholders, I can enter something here. That's the template. So I can configure the template how it looks like. Maybe I want to have 2 procedures for this package. I want to test maybe a positive and a negative one when I generate the package. So let's do that. I go here to the utPLSQL preferences. You see here we have several tabs, and one of the tabs here is to generate code. The first thing I do, I change the prefix. I change it here to T3, not to be in conflict with my other ones. And then I'm going to add here an underscore and say, let's create two tests per unit I find here. Let's create them disabled so I just can run them and just update my code templates. And when I go here to the code templates and look at the same body here again, I have to click on the right one. Huh? Then I see here that two test packages are generated, are predefined. So that's the template I want to use. So now I'm ready. I configured my template the way I like it. Of course, you can may do additional configuration if you want. And then I can right click and say here, generate utPLSQL tests. And check, you see, it's quite fast, 500 lines of code generated. You see here that's right now. Oh, already 1743. Yeah, we have to get a bit faster here. I see the test suite here, and I see something new, a context. That's quite nice. I have grouped these tests which belong together with a context. So these two procedures are testing the load from tab procedure. These tools are disabled. And the next two procedures are testing the load from view procedure. That's nice. So I can group them. So when I go down here, I see that's the package specification, and afterwards the body. A lot of package bodies are implemented with the default we've seen with an actual 0 and expected 1, and I can install that. So this should work. So now when I do a refresh here, I should see my T3 package, and I can run utPLSQL for that one. So and what I see here also is I see this nice hierarchy. I see this load from tab and the context and this grouping of these tests. All these tests are disabled, and I could start here, implement one of these procedures. You can go a step further, and yeah, that's not real life, but technically I show you what you can do. You can generate for all your code in a schema utPLSQL tests. So I have to do that here. When I go to utPLSQL, I can look for types. I can look for procedures. I can look for functions, or here for packages. When I click here on packages, I see that I have basically only 6 packages here. But when I go back here to the navigator, I see I have more. But all these tests that are annotated with as test suite are not shown here in the generator. So I can go here and call the generate dialog, and all the information I've got in the preferences I can oversteer here, and I can change something I want to do here, maybe choose another prefix, T4, and accept the rest and generate the stuff in my worksheet. In this case, we have not created everything in a single worksheet. We have created files. So I can open up, for example, this file here. Was the wrong one. File open. And I see that there's the file with the package specification. And there is also a file for the package body and so on. So there's something you can check in your version control, and it's better suited than everything in a single worksheet. So install that just to demonstrate what we have generated here. Go back to my navigator tree and see here my T4 packages. I can mark them here, run utPLSQL tests, and I see 60 tests are generated, all are disabled, and I see them here in a similar way. I can go back and basically, for example, also run tests for a complete schema, and I see now that we have 117 tests. A lot of them are disabled, and I can go here and say, I don't want to see the disabled tests. There are just rubbish. So I have those that are really have been completed. That's nice. I can also sort the stuff by time, but when I click here, it doesn't work because it's a tree. So I have to switch to a tabular view, and then I can sort that by time or by description or successful tests. For example, can mark this one and rerun them. Maybe they are faster when I try it again. Maybe I try again. No, they are not really faster. I can jump back to my previous execution and so on. So you get an idea how you create tests and run tests within SQL Developer. Close that stuff. Don't need that anymore. No question. Sam is answering. Thank you, Sam. So I have no chance to watch the chat while presenting. This does not work. It works when you watch the audience, but it doesn't work when you watch the chat. So let's go back to the presentation and let's cover the next topic. You can also run code coverage reports in SQL Developer. And the next question is, what is code coverage? So basically, here's a definition from the Wikipedia. In other words, you just run a set of tests, and utPLSQL is looking how much of your code base has been touched by these tests. So you see, I have a good test coverage or I have a bad test coverage. That's the idea. So let's look at it by an example, a very simple example. Let's look at line coverage first. I have here a function f. Function f, which gets a parameter a, which is an integer, and it returns an integer. And the code is pretty simple. If the value is a null, then it returns 0. If the value is not null, then it will multiply the integer it gets with itself, and it returns it. So here's a question for you. It's already late, but I guess you can answer that. How many test cases do I need to get 100% line coverage? So who has an idea? So I'm watching the chat for some seconds. It's just one digit you have to enter and press return. Shouldn't be that complicated. No? No one wants to answer? 3? Almost. What's that? More than 3? No, not 4. Okay, I stopped that. It's 2. It's true. Actually, it's 2. I explain it. When you pass a null value, it will go through all these lines, through the 0, and then to the end if, and you're done. With the second test case, which is a not null value, you go the other path here to this return value, and you're done. And when you run both test cases, you have 100% code coverage. That's the idea of line coverage. Let's reformat this statement. I can write it this way. I have also a presentation about formatting. It's another topic I like to talk about. And what I've done here, I just removed all new lines. I removed some white spaces, and basically the code here is on a single line, the relevant code. Of course, I could also put everything else on a single line, but it's not very suited for PowerPoint. So the question now is, again in the chat, how many test cases do I need right now to get 100% line coverage? What do you think? Also 2? Other opinions? 2? Yeah, that's what we would like to expect. So that would make sense. Line coverage 1, yes, Pete, of course. 1 is 4. Oh my God. Null, negative number, positive number. These are good test cases, but really for line coverage, you just need 1 test case, because whatever the value here is, you're going to touch this line of code. And then you have 100% line coverage. So you see a bit the flaw of line coverage. It's depending how you are formatting your code. So Oracle 12.2 came up with a new capability that is called code block coverage. And code block basically divides the code in several blocks which can be executed only as a whole thing. And therefore, this code block coverage is completely independent how you format your code. So with code block coverage, I have basically 3 code blocks, everything up until to this return, then everything after the return from else to that one, to the rest of it. So these are these 3 code blocks. And when I run code coverage, with 12.2 code block coverage, I need 2 test cases to get 100% code block coverage. So you see, code block coverage is a bit better. So let's rewrite that statement once again. So let's rewrite it this way. So I could write it much terser, much maybe other would say simpler. I just can use a coalesce function instead of an if. And with a coalesce function, just the first not null value is returned. So how many test cases do I need for this function to get 100% line coverage and 100% code block coverage? What do you think? Still 1? Other opinions? Right. It's 1 test case if you pass a null value. If you pass a null value, then this code block is touched and also this code block is touched. So it's really cool. These code blocks work also on these functions. So, but nonetheless, there are some flaws with this matrix. So let's look how utPLSQL presents the results of line and code block coverage. I have the test case here. I haven't shown the implementation, I guess. It's quite simple. The test package here, the actual value is based on the function with a 2 parameter, not null value. Therefore, I expect before, and here's my expectation. And when I run this test code, I run this test code with the implementation based on the coalesce. So it's a not null value. It will touch this A multiplied with A, but it doesn't touch this part of the code. So we get 100% line coverage, but it will say also that just half of the code blocks are touched. So the question is this helpful? Is this good? So let me jump to show that on the example we implemented before, the T2 package. Maybe you remember the one that I created from scratch from the beginning. I can run also code coverage from here. So I just select the package, say code block coverage, and what utPLSQL does, it calculates the dependencies and say, hey, I have to include these packages to get the 100% view. It's a bit too optimistic, so I remove a bit and run that. So I see the runner, and after the runner has been completed, then I see the result here, the code block coverage in my browser. I can click here on it, and I see the results. I see, oh, that's my load from top package. Really, I call clear depth all. That's why these procedures here touched. I see this insert statement that goes up until this is 1 statement. So this is executed, the commit, and that's 1. So everything is touched here twice for the first test and the second one, and I get other information that the other procedures in that package have not been touched. So that's quite nice. So let's just run the code coverage for the first procedure we implement. This time I just accept the default and I get the similar result. It's in fact the same block coverage, and I say get here the same results from the color perspective, but all these lines have been touched only once. Previously I ran both tests and I seen they have been touched twice. That's the difference. Otherwise, they are the same. So let's go back to my previous run and run the compare rows case. I should have not run it. I should have run code coverage for it. It's a difference. So, and when I run that, again, it looks 100% the same like the previous one. So maybe let's scroll up. Sharing screen stuff. So you see, this looks really the same. And the only difference is to the whole run is the number of times something has been touched. So when I go back again, I think that's in here or here. And I think I've already found out that counting rows is not really necessary. So from a code coverage perspective, both tests are equally good. Both are touching 100% of the code. So from that metric point of view, it doesn't matter which one I'm going to eliminate, right? So I can eliminate that one or that one, it doesn't matter. But that's certainly not true. In the end, code coverage covers that part which has been executed, but the value also in the test was that part here, what I'm going to compare my assertion. And the second test, the compare rows, is much more thorough. Every row, every single column is compared. And I don't get this information in the code coverage by that. So there are a lot of flaws when you just look at the metrics of code coverage. I personally like code coverage just to make sure, because I got the impression I touched this code and I want to check if I've touched this code. For that, it is good. But just looking at the metric and you get some metric like 95% code coverage and therefore the testing must be thorough and good, that's not really true in my point of view. So be cautious when you look at that things. So that brings me to the core messages. And the core messages are 3 actually. So from my point of view, when you start testing it, it is really hard because you have no idea where to start. So there are 3 tips from my point of view to start with. You already heard some from Sam and follow them as well. They're good. So my first tip is make your environment test friendly. So install utPLSQL core in your databases you are working with. Ask a DBA to help you that. It's not that complicated, but you need a bit higher privileges to install that. And then it's available. So if you want to use it, you don't have to, it would be nice to have it. You already have it in your environment. That's step 1. And the step 2 within that task is install also the utPLSQL extension in SQL Developer if you are working with SQL Developer. Use the extension in PLSQL Developer if you work with that tool. Use the extension in Datagrip or Tort if you work with that tool. So it helps you to work with utPLSQL. I showed you that in the demo, and I encourage you that it is really, really fun and helpful to work with it. So that's the first recommendation. And the second recommendation is, where do I start with? So my recommendation is start with the very first step when you are going to reproduce bugs. So that's what I've done. And I think it's a good starting point because at a certain point you have to reproduce a bug anyway. So when you try to reproduce it with a test case, then it fails and you have something which will succeed afterwards. That's a good learning experience. It won't result in a good set of test cases like Sam recommended, like a documentation of something, but at least it's a good starting point. And the question is also, should I use that tool I showed you to generate all the skeletons for a whole schema? Is this really a good idea? And to be honest, no, this is really a bad idea to start with. It's nice. It gets you a lot of tests, but you have to maintain all this skeleton code. It's not really fun. It might be helpful to start with a certain chosen package where you want really to implement everything, but not doing it the bulk way. I don't think it helps. What is helpful, in my point of view, is to start writing tests for new requirements. So, and this has two advantages. The first one is you have to think about how to test this, how to write the test, and this brings me to the next one. When you start using utPLSQL, you want to call certain parts of your code. You don't wait until the end, until you test something, until you run something. So you want to run certain parts of it. So you think about isolating code and testing that isolated code itself. So you write smaller units which are testable. And this is, from my point of view, really a good development when you start writing tests. When you look at the legacy application and you want to make sure that your new functionality does not break existing functionality, it's really, really hard because you usually don't have the right entry points, and writing the setup for the tests is everything but simple. So from my point of view, starting with to reproduce bugs is a good case. Starting with new requirements is also a good case because you have there the chance to steer what the code is you are testing. So that's it. So I hope you got some expression how utPLSQL works, how it is supported in SQL Developer, and I'm ready for some additional questions.
Philip, can you hear me?
Yes.
Okay. I have a question. You say you write smaller units because obviously those are easier to test, but usually when you develop your PLSQL, you develop a package with just a couple of functions and procedures in the specification, and a lot of the code is in smaller units inside the body that will not be exposed to the outside world. But if you want to test them with utPLSQL, you're going to have to expose them in your specification. How do you go about doing that?
Yeah, basically the idea is the main recommendation is don't expose something just for testing purposes.
Yeah.
So you test the other stuff outside. There are also some hacks. I think I have a blog post about it, how you can do that, to work around it and even ship it in production without changing the specification. I cannot recall it right now, sorry, but how to do it, but there are ways. But from my point of view, I just wouldn't go that way. If you don't have it that way that you're going to expose these functions, then don't do it. What's the possibility is that you have maybe in your project the concept of private packages, which are just there in the schema, but you don't have grants on them. So that's a possibility to work with it, but it really depends on the project. But I wouldn't start exposing too much. But maybe there are some utilities which you can expose and make sense. But you think more about it, how to do it. Maybe what you do what you write in a view or what you write directly in a package, something like that.
Yeah. Would it be an idea to use conditional compilation for this?
Yes, so conditional compilation was one option. I just have to check. I have it in my blog. Sorry, I will find that. No, that's not that post.
Okay. I'll find it myself, don't worry.
I have to find it. Yes. I think it's possible to use it with accessible by clause. You can define that. That's the idea. Yes.
Yeah. Okay.
You can use the accessible by clause, and the advantage is then that you don't have to change the code or have conditional compilation, because I try to avoid conditional compilation whenever possible.
Yeah, me too. I don't like it.
but that it's an option. Yes.
Yeah. Okay. Thank you.
If you allow me to chime in, Philipp, there is also some nuance to that question from a test-driven development perspective. I just want to drop that here, because when you do test-driven development, you agree to have a certain architectural style. And one consideration of this architectural style is, what is a private function? What is a private piece of logic? Why not expose it if it's necessary and if it can be reused at some other point? So it's not always the question, how can I hide it, but what's the problem with having it exposed? Right? Because if it's well tested for all the cases, there is no problem to have it publicly available.
Yeah, it's from my point of view, it really depends, because you are exposing functionality which you don't want to expose that way. So it's something,
and that's the main question.
That's the main question. So if it is that way, I don't want to make it go to the extremes and make it the API, because then I'm bound to it. I want to have my API as small as possible. But APIs, you can manage that with grant. So there are different ways how your architecture works. But in the end, I want to have a tight API and have a playground where I can change things without asking anyone. That's the main driving force, and that's also the driving force for hiding something like private functionality. But you're right, it really depends. And I've also done that and exposed some of those functions sometimes. There is a question in the chat.
Depends.
Yeah, it depends. That's always the right answer. Compare rows functionality covers also duplicate rows and identifies the duplicate row. I don't.
In cursor comparison, yes, because it does a count and it also hashes the columns.
Okay, you know it by heart. I don't know it by heart. Good to have you here in the call. Thanks, Seb.
I'm like 98% sure.
Okay, I would try that. Okay, if L actual have duplicates, so that was just clear. Yeah, it should work. Yes.
And there is another question a little bit above. Can utPLSQL help identify deadlocks? For example, when procedure executes an update, but the sum table rows are locked by other session?
I know that Jacek and his team of pretty experienced utPLSQL users managed to test that, yes. But I guess it's not very easy, but
it's not the default case because utPLSQL is, as a principle framework, single-threaded, and to achieve that you have to have some code which works with multiple sessions somehow. And if you do that, then it's possible. Yes, I guess. But in that case, I would ask directly Jacek if he has implemented already. What you can do is you can also, instead of asserting, you can also say it's okay when a test case throws a certain exception. So you expect that a certain exception is thrown. So this would work quite nicely. But managing these multiple sessions, this is some kind of hack. Okay.
Just to make that clear, utPLSQL is not able to detect timeouts, but deadlocks will come with some error at some point, and therefore it's possible to test against it. But you cannot say run this test for like 30 seconds, and if it doesn't finish, then abort. That's just not possible by the way PLSQL is designed.
It will abort usually after 5 minutes, I guess that's the default for locking issues. But yes, you're right. You don't want to have this kind of tests when it doesn't work really fast enough. Good.
Good. So, any other question? You can open your microphone and talk. Everyone can open it. If it's difficult to...
Yes. Usually would get a beer. I don't drink beer, so I have here mineral water. So, Prost, what do you say in Romania?
Noroc.
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 So, if there are no other questions, we can close the evening. Thank you very, very, very much, Philipp, and thank you very, very, very much, Sam, for your very interesting presentation this evening. People can follow you on Twitter and can read your blogs and find out more about these topics. Someone is asking if they are getting the slides.
Yes.
Yes.
The slides are on. I can show it here. I have on my webpage on my blog salvis.com. I have the talks, and you find here the slides of the newest one. And this talk is also available as a video. And I guess you also recorded it, right?
Yes, I'm recording.
So we get the recording with all the jokes and fun between, so you can rewatch that. Or will it be edited out or what?
It will be edited out.
Okay, I see.
Yeah, as usual, Philipp is prepared better than me. I don't have a post up, but I will have, and you'll find it on my website. I just leave a link here.
When you click it here, it will open up and you get the slides. And the video is quite similar, so you see that. So when you want to follow that, and if you have questions, don't mind to contact me via LinkedIn or via my website or email. Just contact me and ask.
Okay, so hopefully next time we will meet in person in Romania, right?
Yes, I'm looking forward.
Okay.
Okay.
I would love
Let's
to.
Let's see what the next year will bring.
Yeah, it will be better at a certain point in time.
Yes, we all hope so. So thank you again. Have a great evening, everyone, and see you on our next tech session, 30 of March. Yes, end of March.